We got two more multiple choice, and then we move on to true false. So first question is just about what statistically significant means. Statistically significant is when we reject the null, we say that there is enough evidence. And yeah, we do that when the p-value is less than the significance level. Simple as that. 19 is a duality question. We're talking about confidence intervals and hypotheses together, which means this is all about that idea of outside. If our value falls outside the confidence interval, we would reject the null and vice versa. So in this case, they've given us a p-value and a bunch of confidence levels. So I like to take these confidence levels and change them into alphas, because we know for a two-tailed test that our confidence interval level and our significance level for the corresponding test are complements of one another. So if we look at this, 0.06 is less than 10, but greater than the other two. So this is the only one where we would reject the null, and that value would not be included in the interval. So our answer choice is A. I realize that these explanations super fast, but I have so many other keys to make before the end of the day. So hopefully when you look through this slowly, it will make sense. Trust me, it's a question we've done before. All right, and so I don't have to start and stop a video. Let's just look at the true false. Central limit theorem states that for a large enough sample, any statistic will follow an approximate normal distribution, even if the population was non-normal. This question or statement is so close to true, but it's not. The issue here is that it's not any statistic. It's only the sample mean that we know this about from the central limit theorem. So we can't say any statistic. We don't know this is true about standard deviation or medians or modes, right? There are a bunch of other statistics that can be collected from data that we don't know this about. We only know it for sample means. 21, p-value gives us a measure of the probability of observing a particular sample value if the null is true. Almost perfect. We needed that or more extreme. I think I meant to write that when I wrote this test. So I think I counted both or just threw this one out, but theoretically, it needed that extra little bit. 22, if we decrease the significance level, we increase the power. So if we decrease alpha, we make it harder to reject the null, and power is all about rejecting the null incorrectly. So this is not true. It'll actually decrease. We had a long discussion about this earlier. But yeah, this is off, and that's because they're both related to rejecting the null. So if we make it harder to reject the null incorrectly, we also make it harder to reject the null correctly.